Let's do some more practice word problems. Patricia is building a sandbox for her daughter. It is to be 5 feet wide and 8 feet long. So let me draw that. So the 5 feet wide, it is to be 5 feet wide. So there you go. That's 5 feet right there. And 8 feet long. I'll do that in orange. 8 feet long. So this is like if we're looking down on the sandbox. 8 feet long. 8 feet long. So the sandbox, if we're looking down on it, would look something like that. That would be 5 feet. And then this side over here would also be 8 feet. All right, she wants the height of the sandbox to be 4 inches above the height of the sand. OK, so if we were to draw the sandbox like this, so if we were to draw 3, so that's 8. That distance right there is 5 feet. And then there is some height, which I think we're going to have to figure out. So let me draw the whole box just like that. Just like that. The sand is going to fill a certain amount of the sandbox. So the sand is going to fill maybe until right over there. So that's how much the sand is going to fill of the sandbox. So all of that is sand. And she wants the height of the sandbox to be 4 inches above the height of the sand. So she wants this distance right here, the amount that the height goes above the sand itself, to be 4 inches, or a third of a foot, depending how you want to think about it. Now, she has 30 cubic feet of sand. She has 30 cubic feet of sand. So this sand right here is 30 feet cubed. How high should the sandbox be? So this information right here, the volume of the sand, tells us, using it, we can figure out how high the level of the sand will be. Because let's view it this way. Let's call L, or maybe let's use x. Let's say x is the height of the sand. X is equal to height of sand. So the total volume of our sand is going to be the height of the sand times the length of the box times 8 times the width of the box times 5. And this is going to be the total volume, which they told us is 30 cubic feet. It is 30 cubic feet. We're taking x feet times 8 feet times 5 feet. So we'll get 30 feet cubed if we were to keep track of the units. So what is this? 8 times 5 is 40. 8 times 5 is 40. So we get 40x is equal to 30. If we divide both sides by 40, both sides of the equation by 40, let me do that. You divide both sides by 40, you get x is equal to, that just becomes an x. X is equal to 30 over 40, or it equals 3 3/4 of a foot. So this right here is going to be 3/4 of a foot. Now what is 3/4 of a foot? We know, let's see, 3/4 of a foot. We know that there are 12 inches per foot. The feet cancel out. 12 times 3 over 4 is what? You can divide 12 by 4 and get a 3. Divide the 4 by 4 and you get a 1. You get 3 times 3. This is 9 inches. 9 inches. So the height of the sand right there is 9 inches. Now, she wants the height of the sandbox to be 4 inches above the height of the sand. So this is 9 inches. She wants 4 more inches. So what she wants, the height of the sandbox, it should be the 9 inches of the height of the sand plus 4, which is equal to 13 inches. And we are done. Let's do the next problem. It was a sale day in Macy's, and everything was 20% less than the regular price. Peter bought a pair of shoes, and using a coupon got an additional. He got an additional 10%. Let me do that in a different color. He got an additional 10% off the discounted price. The price he paid was $36. The price he paid for the shoes, let me do that in a different color. The price he paid for the shoes was $36. How much did it originally cost? So let's just use, so x is equal to original cost. So there was just a regular sale on that day. Everything was 20% less than the regular price. So using that information, on that day, if you wanted to buy the shoes, the cost of the shoes would be x minus 0.20x, or 0.20x, which is equal to 0.8x, right? If you have 20% off of a price, you're going to be paying 80% of the original price. So this is the price that everyone would have paid without a coupon. And that's what that line is telling us right there. Now, Peter got a pair of shoes, and using a coupon, got an additional 10% off of this, an additional 10% off of that. So he's paying 10% less than this. Or another way to think of it is he only had to pay 90% of this price, right? If you take 0.8x, and from that you subtract 10% of this, so from that you subtract 10% of that, of 0.8x, right? This is the same thing, right? This is a 1 times 0.8x. This is the same thing as 1 minus 0.1. So this is the same thing. This is equal to 90% of 0.8x, of 0.8x. And it might actually be very natural for you to go straight to this. It's natural for me. If I'm paying 20% less than the regular price, that means I'm going to pay 80% of the regular price. And then if I get an additional 10% off of that, that means I'm only going to pay 90% of that. So this is what he's going to pay. And they tell us that that price is $36. That price is equal to $36. So if we want to figure out x, well, we can multiply 0.9 times 0.8. Let's do that. So 0.9 times 0.8. 9 times 8 is 72. We have two numbers behind the decimal, 1, 2. So it's 0.72. So you get 0.72x is equal to 36. Or maybe we could say 72 over 100. 72 over 100. X is equal to 36. Or we could even say this is the same thing as, what is it? That's the same thing as 36 over 50, right? 36 over 50. X is equal to 36. And this isn't even in lowest common forms. This is the same thing as 18 over 25. But I like this number because I have a 36 here. And so I can multiply both sides by the inverse of this, 50 over 36 times this. I have to do it to both sides of the equation, 50 over 36. 36's cancel out, 50's cancel out, 36's cancel out, and you're left with x is equal to $50. The shoes originally cost $50. Next question. Rosa has saved all year and wishes to spend the money she has on new clothes and a vacation. She will spend 30% more on the vacation than on the clothes. So let's see that C is amount spent on clothes. She's going to spend 30% more on the vacation. So let's say V is equal to the amount spent on vacation. Well, they just told us that the vacation, she's going to spend 30% more than on the clothes. So the vacation is going to be equal to the amount she spends on the clothes plus 30% of the amount she spends on the clothes. And this is the same thing as 1.3. 1.3 times the amount she spends on the clothes. That's how much she's going to spend on the vacation. Now, if she saved $1,000 in total, how much money to the nearest whole dollar can she spend on the vacation? So between V and C, she can only spend $1,000. So V, vacation, plus her clothes can only be $1,000. And so we know what the vacation is in terms of the clothes. We can do a little substitution. The vacation is going to be 1.3 times the clothes. So we can substitute there. So you have 1.3 times the clothes. That's the vacation expenditure. Plus the amount she spends on the clothes is equal to 1,000. This is 1.3 plus 1 is 2.3 times the amount of clothes is, the amount she spends on clothes will be equal to $1,000. Divide both sides by 2.3. I'll get the calculator out for this one. So we have 1,000 divided by 2.3 is equal to $434.78. So C is equal to, I already forgot the number, 434.78. $434.78. So that's the amount she spends on clothes. The rest of her money is going to be spent on a vacation. So her vacation is going to be at 1,000 minus this. So her vacation expenditure is going to be 1,000 minus 434.78. I'll do the calculator for this one. So let's see. Let's make this into a negative number, and then let's add 1,000 to it. And we get $565.22. So $565.22. And I'll leave it up to you to check it. This is how much she spends on the vacation. These add up to $1,000. And this should be exactly 30% more than this amount, the amount she spends on her clothes.